Good morning, everybody. This is our formula sheet. You should have it already, and it is yellow. I realize that it has advanced pre-calc on it. We, in traditional, focus on the front. In advanced, they talk about some of them on the back, and I thought it would be a good idea for you to have all of them on one sheet just in case you happen to need them in the future and you keep your pre-calc binder. The ones that you will need for calculus, however, are just the ones on the front. So those are the ones that we are going to focus on. Before we get started, the ones on the top here, we have actually already covered. Tangent, we learned, tangent of an angle, we learned was y over x. Well, y is the sine, and x is the cosine. So another way of writing tangent is sine over cosine. We also know that tangent and cotangent are reciprocals. So you could say that tangent is the reciprocal of cotangent, and we signify reciprocal as 1 over the value. We learned that cotangent was x over y, otherwise known as cosine over sine. And again, cotangent could also be referred to as the reciprocal of tangent. Sine could be referred to as the reciprocal of cosecant, or you can say cosecant is the reciprocal of sine. Cosine is the reciprocal of secant, and secant is the reciprocal of cosine. So these are not new. We're going to talk about these three new ones in a minute, and then over here on the right are just other ways of writing these exact same. So these are your three main ones. And then if you look over here, this is cosine squared theta plus sine squared theta equals 1. All they did was move the cosine to the other side by subtracting it. So 1 minus cosine squared is the same as sine squared. Same thing, if you move this sign to the other side, it would become negative. So we would have 1 minus sine squared theta equals cosine squared. You may want to add your even and odd function facts onto your sheet. Like if I had my sheet here, I'd probably say, cosine of negative x equals cosine x. Because if we learned during the even and odd unit, if you have a negative argument on cosine, you can just drop it. Same thing with secant. You can just drop it because whether the argument is positive or negative, you get the same answer, and we're not allowed to leave a negative argument. All four of the other ones, you have to pull them out in front. So for example, if you have sine of a negative argument, we write it as the opposite of sine of the positive argument. We just pull it out in front. Same thing if it was cosecant or tangent or cotangent. A better way of writing it for what we're moving to next is the opposite of the trig with the argument. Okay, so these are the two that you ditch it or just drop it, and these are the four where you can pull it out in front. Okay, so let's get started figuring out where these come from, because I don't like just saying, hey, these are true facts without proving it to you. All right, so this is page 1 of Trig Packet 3. Question 1, what is the equation of the unit circle? We had this in one of our notes before, but I'd like you to fill it in. X squared plus y squared equals 1. I also drew a unit circle over here and put a triangle in it. This is x, this is y going up and down, and our radius is 1. So you could think of it as Pythagorean theorem. X squared plus y squared equals 1 squared, which is 1, if that helps you remember it. Which trigonometric function can be substituted for x? Well, our x value is the cosine, so cosine theta. I'd like you to fill in for number 2. Number 3, which trigonometric, it's a hard word to say sometimes, function can be substituted for the y variable? Well, y is the sine value, so I'd like you to put sine theta. And remember, this right here is the Greek letter theta that we usually use for angles, theta. Question 4, rewrite the equation of the unit circle, which was up here, using trigonometric functions. This is the first of the 3 Pythagorean trig identities and recorded in your table. So instead of x squared, it's cosine theta squared. And instead of y squared, it is sine theta squared. In trig, when we need to square something, we write the square between the trig word and the argument. So it's cosine squared theta plus sine squared theta equals 1. You could write it like this, although I will tell you that you would rarely see it this way. They mean the exact same thing. I just think this is a shorter way of writing it. You don't have to worry about the parentheses. When you put the square in here, it assumes that the person is going to take the cosine of the value and then square it. All right, so that's your first one. So this is number 1, cosine squared theta plus sine squared theta equals 1. That's our first one. Please make sure you write that at the bottom. And it's not something you have to memorize, but because it is right here on your yellow sheet that you are allowed to use. So that's the first one, but I just want you to know where it comes from. The other 2, I'd like to go over and see where they come from as well. Number 5, divide each term in your first Pythagorean trigonometric identity by sine squared theta. Rewrite the equation without any fractions. This will be the second of your 3 Pythagorean trigonometric identities recorded in the table. So I'm going to rewrite the original one, but now I'm going to divide everybody by sine squared theta. And as long as I do it to everybody, it is a legal algebraic move. So let's see what we get here. Cosine squared over sine squared. Well, if I look on here, cosine over sine is the same as cotangent. So they're actually squared. So what I'm going to rewrite it as is cotangent squared of theta. Because it's basically like having a cosine over a sine times a cosine over a sine. So I have 2 cotangents being multiplied together. Sine squared theta over sine squared theta. When the numerator and denominator is the same, numerator and denominator are the same, I should say. That equals 1. And then 1 over sine squared. Well, 1 over sine is cosecant. So since I have a square on it, I say cosecant squared. Because technically you could write this as 1 squared because that is a 1, and you could square it if you wanted to. So it's like having 2 cosecants multiplied together. Now, if I look on here, they wrote it as 1 plus cotangent squared equals cosecant squared, which is normally how you see it. They write the 1 first. It's not wrong to have it in the order that we have there, but I'm going to write it as 1 plus cotangent squared theta equals cosecant squared theta on our note sheet, because that's normally how you see it. But again, you could flip those around. You'll also notice on here that they wrote the same one 2 other ways. They moved the 1 over and wrote it that way. Looks like they also moved the cotangent squared over and wrote it another way. Just another way of writing it. These are not all the other ways. You can always move things back and forth on either side of the equal sign as long as you change the sign. And then let's go for the third one here. Now, divide each term in your first Pythagorean trigonometric identity by cosine squared theta. So let's do that. Divide everybody by cosine squared. Rewrite the equation without any fractions. Okay, well, cosine squared over cosine squared, numerator and denominator are the same, so it's 1 plus Sine squared theta over cosine squared. Sine over cosine. Sine over cosine is tangent. And since they're squared, we'll say tangent squared theta. Make sure that square, again, is between the trig word and the argument, not all over here to the side. That means something different. Equals 1 over cosine squared theta. Let's look on here. 1 over cosine is secant, but I actually have two of them. So I'm going to write secant squared theta. And that is our third one that I'm going to copy down here. All right, so just a quick review. We added our odd and our even facts at the top. These are ones we had before, and these three are new ones. I will say that this one right here is more popular to use than this one. Same thing here. This one right here I find is more popular than the one over there. So I hope that helps as we move to the trig identity unit.